Hello everyone, welcome back to this video series on derivation of subject level population flags which are commonly used in ADSL. So in the previous videos of this series we have seen how to derive screen failure population flag, randomized population flag, safety population flag. So now in this video we will see how to derive FASFL, which is full analysis set population flag. Let us take a look at the algorithm or derivation logic provided to us. It says create this flag using the data collected in EX and lab LB dataset. It says a subject would be considered under full analysis set only if he is a safety subject, which means the subject should have safety flag is equal to Y and with at least one post baseline efficacy measurement. So here in this case, so we should have both conditions met, safety flag is equal to Y and at least one post baseline efficacy measurement. And they are also specifying us like what additional conditions have to be specified. So for this example, HbA1c parameter value collected in LB dataset is considered as the key efficacy parameter. So we are being given the test that actually is the key efficacy parameter. So populate FASFL as Y for those safety subjects who have at least one post-baseline HbA1c measurement in the LB dataset. That is, subject should have a measurement in LB dataset with LB DTC greater than treatment start date. So as the requirement was post-baseline efficacy measurement, so we are being asked to check the condition whether there is any measurement for HbA1c in LB dataset and the date of collection for that HbA1c is greater than treatment start date. So then only that would be considered as a post baseline measurement. So FASFL will be populated as N for those subjects who do not meet the above criteria. So for Y there has been a condition been given, and for all the subjects who do not meet Y will be considered as N. So now let us see how to manually identify this first and then move to programming approach. So in earlier videos we have seen how to derive screen failure flag, randomized flag and safety flag. For FASFL we need to use information from safety flag because this is part of the condition that has to be met for FASFL. And additionally we were asked to check whether the subject has a particular piece of data in LB dataset. So let us go ahead and see what LB data has. So here we have some measurements related to HbA1c and along with the date of collection being given. So here we need to check whether the subject is a safety subject first. So let us filter for safety subject. And then we need to check if there is a record in LB for HbA1c after 7th December 2011 for subject 1002. So let us check if the subject has any record in LB for HbA1c after 7th December for 1002. So let us filter for 1002 subject first and see the measurement dates. So there is one on November, 7th December 2011, and there are some collections after 7th December. So this subject meets the condition of having a post-baseline measurement for HbA1c. So this subject has both safety flag is equal to Y and also has a record in LB with HbA1c where date is greater than treatment start date. So FASFL for this subject would be Y. So let us take a look at the subject 1004 now. So for this subject, treatment start date is 24th October 2011. Let us come back to LB and then see if we do not have any. Let's try to remove all the filters and then try to see if we have. So subject 1004 does not have any collection in lab dataset for HbA1c. So this means though the subject is part of safety, but the absence of a record in LB for HbA1c is failed. So the subject cannot be called a full analysis set subject. So we should have this as Y. So let us take a look at the subject 1005 in LB dataset and then see if there is a collection after 4th October 2011. Let us filter for 1005 and then see if there was a collection after 4th October 2011. So 4th October, this is September, so this cannot be considered. 4th October, this cannot be considered. So there is one on 1st November. So the subject has one post baseline assessment. So this subject also gets classified as FASFL is equal to Y because the subject is a safety subject and also has a record in LB with HbA1c measurement after the subject's treatment start date. So for all the other subjects, FASFL will be N. So wherever it is empty, we need to fill it with N. So we have identified the full analysis set population flag for subjects manually. So now let us see how to programmatically derive this. So this technically involved safety flag and checking HbA1c presence of HbA1c measurement after treatment start date. So let us see how to programmatically implement this. So what we are trying to do here in this step is, so we are trying to convert because TRT SDT would be a numeric variable and LBDTC in uh, LB dataset is a character variable. So for the character comparison to numeric comparison is not feasible. So we are trying to convert LBDTC to numeric variable and calling it as HbA1c date. So in this dataset, we are converting LBDTC to HbA1c dt and then bringing in treatment start date into the HbA1c data by merging at subject level. So and then we are keeping only those subjects who have a record in both. So if a subject does not have a record in treatment start date, we do not need to consider those subjects because as part of the definition, the subject should have a date which is after treatment start date. So we are using if A and B. And then we are subsetting the records which are only after treatment start date if HbA1c dt greater than TRT SDT greater than missing. So in this dataset we will get all the records which were after which are collected after subject's treatment start date, which means that all the post baseline collections. But we need to identify only those subjects which have identify the subject who has at least one record which is meeting this condition. So we have seen that for one subject there were multiple collections after treatment start date. So in order to simplify the merge, we are keeping only one record per subject who has at least one baseline. So here we will in HbA1c we will have all the records of the subjects which are collected after treatment start date, but we need only to identify the subjects. So we are keeping one record per subject by employing no-dup key on this HbA1c data and outputting the records to HbA1c dt. And then we are using that data set in the merge to our DM along with some other additional information which has treatment start date and randomization information. So for safety flag, we need a treatment start date and randomization flag. And for FASFL, we need information on HbA1c and also treatment start date. So what we are doing here is the previously derived SAFFLY is being used and then checking for the presence of a record in HbA1c. And H means, so there is a record in HbA1c dt, which in turn means that the subject has a record with a collection after treatment start date. For all those subjects, we are populating FASFL as Y, and for the other subjects, we are populating FASFL as no. So let us run this piece of code and then see if we are getting the same values as we have manually identified. So N, Y, N, N, Y. So the subjects are in the same order here 1001 to 1005 N, Y, N, and Y. So let us see if that is the case. N, Y, N, N, Y. So we are getting the same result as how we have manually identified with the programming approach as well. So this is how we can derive and implement some logics to derive any analysis flag. Here in this case, we have seen it for full analysis set flag.